Hi, my name is SYAZANI. So I'm going to demonstrate the test 3.2.1. Click File, New Project. Then put the name Lab1 Task 3.2.1, and then click OK. Okay, create a blank project. Click OK. Okay, wait for a minute. Then select place part from right window. Okay, to search the component register, type R. Okay, for this circuit we need two resistors. Then for the power supply, VDC. So for the current, IDC. And last component is ground. Okay, we need to rotate resistor 2 and mirror bulb for IDC. Then select the wire and connect all the components. Oops. Value for resistor 1 is 20 ohm, and for the resistor 2 is 24 ohm, and for the current is 6 ampere, and for the VDC is 1 to 0. Okay, then click Spice and new simulation profile. Okay, put the name Lab1 Task 3.2.1. Then create. Then run the simulation. Okay. Click Spice bias point and enable bias current display. Okay. And enable bias voltage display. That's it for this task. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Isman. I will explain about part task 1 in part DC switch. After we draw a schematic as shown in figure 3, which is we use a diode D1 and 4148 and resistor right here and voltage DC as V1. And R1 we use my IC number, which is 20 ohms that are using 2 digit at the end of my IC number. For the setting in PSpice, I will already make sure the switch variable is voltage source, which is I rename is V1, and make sure the type is linear and use 0 volt, 1 volt and 0.0 volt for the start value, end value and increment respectively. After that, I will run the simulation. Okay, you can see when the simulation has finished, you can see it is a black window with no graph. Okay, so let me setting here to make the diode current vs diode voltage. Okay, after that I slash the trace and add trace from the trace menu and I slash ID1. After that I change I want to change a x-axis, which is I select the plot and axis setting from the plot menu and click on axis variable, and then I slash VD1 1. Now I look the value of VD1 when the current ID1 is 1 milliampere. After that I slash the trace and cursor, and then I click display from the trace menu. A small window called prop cursor will appear, and you can see there's a table. There are two cursors where A1 is controlled with the left button of the mouse and A2 is controlled with the right button of the mouse. When I have at the point, I select the plot and label mark from the plot menu. The coordinate of the point will show up, and you can see the coordinate will show up. And lastly, I select the plot and label, and I select the tag from the plot menu, and I type a diode 6 characteristic and press on the plot by moving the mouse. And you see that's all of my DC circuit sweep analysis.
Hi, it's me again. So I'm going to demonstrate test 3.2.3. Okay. Select file, new project. Then put the name Lab1 test 3.2.3. Okay, click OK. Then create a blank project. Click OK. So wait for a minute. Then we select place part from the right window and search for the component resistor, which is R. Then for capacitor, then for the power supply AC, VAC, and the last component is ground. So we rotate the capacitor and select the wire and connect all the component in one series. Okay. Okay, change the value resistor 1 for 24 ohm and for the capacitor 1 micro. Okay, click OK. Then click PSpice. Okay, new simulation profile. Then put the name Lab1 Task 3.2.3. Then create. Okay, on this side, we need to change the analysis type to AC switch. and put the value for the frequency, which is 0.1, and make sure this logarithmic is decayed. Okay, for this value 0.1, then 10,000 and 101, apply, then click OK. Okay, then run the simulation. So it will appear like this at first. So click trace, add trace, and find this slash with this, then click OK. Then it will appear like this. So we get a graph. Then we click trace, console, and display. Okay, trace, console, and point. Okay, find the 0.707, which is that we found by using a calculator. So this is the point. Then we select plot, label, and line to the point that we found, which is 0.707. Then we select plot, label, and line again to the 1 Hz. Okay, then we select plot, label, and this time is arrow for both sides, left and right. Plot, label, and arrow. For the right side, then select plot, label, and text, and put it bandwidth. Click OK, and put at the center. So that's it for the task 3.2.3.
Okay, next I will present about the estimation in time domain transient in task 1. Okay, so after I draw the symmetric action in figure 6, which is D1, we are using a diode D1 and 4002 resistance, which is I use my IC number 420 ohms. Okay, so I also use V1, which is it is V sinus, and then I using ground. Before we run the simulation, I already setting the time domain setting, which is run to time equal to 0.05 second and start saving data equal to 0 second. I also set the maximum step size in transition option to 0.005 seconds. And then I put the voltage or level marker at the node as shown in the figure 6 which is at the middle, at behind of diode D1. Okay, so I run the simulation, and you will see there's the graph we get from that circuit. After we run the simulation, we got a sinus graph. So and for the resource D11, we got is a completely sinus graph, which is a 180 for the positive line and 180 for negative point. For voltage resistance, we got only positive line we got, and after it reached 0 voltage, it become flat at this area. Okay, next, now we change R1 load into R1 L1, which is same as figure 7. We did a remain constant type of diode, and the value of voltage source, which is we are using V off equal to 0, V amplitude equal to 100, and frequency equal to 50. The value L1 we set is 60 millihenry, and the value of R1, which is in my IC number, it is R equal to 20 ohms. After we run this simulation, we can get it is a lot of different from the graph before, without inductor in the simulation before. After we run the simulation, it has a lot of different of the graph. We can see we got a breaking point at this area, and it become the same as a graph before we start the task of the time domain simulation.